Hello and welcome to this very quick overview of agile development using the Freebird application. So we're going to jump into it. We'll start by going to the Eclipse Freebird Tools GitHub repository, and we'll go to the develop branch, and we'll start what's called a code space, which is a zero install way of using the application. Let's start the application. We'll type in this in the terminal. And it will open the application in a browser for us. Takes a minute or so to start. We click open in browser, use the application, we go to the task workflow dashboard, and we'll see we're going to get all our bird artifacts from a GitHub repository called Freebird, and then we're going to make some changes to the artifacts, and then we're going to ask for those changes to be reviewed and approved and be merged back into the Freebird GitHub repository. So first we get the artifacts from the GitHub repository by clicking retrieve artifacts. This takes about a minute, so let's pause the video. Okay, that's completed. Let's set up the database. It takes a couple of minutes, so let's pause the video. Okay, that's completed. We now have a bird database. I'm going to run these 4 tasks. SMCube's core creation, and then from the core SMCubes artifacts, create the transformation rules in SMCubes, then translate those into Python, and then execute those against test data and expected results. And we can run all 4 tasks individually and step by step because they have subtasks, or we can just run all 4 here by doing run auto mode to task 4 from task 1. That will take a few minutes, so let's pause the video. Okay, that has completed. Let's review some of the results, like the tests. We have like 4 tests. They're basically checking, they're loading in something called loan and guarantee scenario 1 and 2, which is test data, testing some data points in FinRep FO5, and seeing that if the expected results that we specified matched with the results actually produced by executing the Python transformations. So this is something we can run after every single change to make sure that we regression test every change as soon as we make it. We don't wait for months before we do these regression tests or even tests of changes to transformations. Let's look at the SMCube's transformations. Let's look at the cube links, which is how we map the link from the output layer to the input layer. Let's look at FO5. Let's look at that for other loans. We do cube links here per product. Apply filters. This is in SMCube's format, and we do view network. And we see all of these things that if I'm carrying amount should be for other loans, it should be carrying amount from balance sheet recognized financial asset instrument. In this case we're using the LDM. We can do the same exercise, exactly the same for the input layer. Let's say for, I don't know what's a good example, institutional sector, if I'm in the F05 output layer, institutional sector should be mapped to party in the input layer. So this was done by a sort of fairly smart algorithm, which is helped by the fact that our output layers are derived very clearly from the precise annotated templates provided by the EPA, and those are translated into STD, the Dictionary of Bird. And on the other side, we have the input side, we have the very detailed LTM. So it's very easy to make, well, it's very possible to make a very good match from output layer to input layer. Now, let's imagine this match went a bit wrong, and actually it chose institutional sector, but we should have chosen something else. Doesn't really happen very often, but we allow ourselves to edit, and so we'll make an edit, and then we'll push that change to be reviewed by an authority to say it can be linked into the sort of master version of these artifacts. So that's what we're going to try to do today. How do we edit it? Well, let's go back to review. We say edit cube structure item links. And we'll find this one, which was F0501. The details going from party here, and for other loans was the example we were just looking at. Okay, so it shows us one of our they're called CubeLink items. Here it says we're going from to institutional sector, and we're going to make a change. We're going to add a new link saying that we actually want to go for institutional sector in our target. We want to go from not institutional sector in the source. We have a limited set of source things, but from party type. Completely wrong, but we're going to imagine this as our change. So if we then go back to look at the links, we'll see our second one. 51 party other loans. We're going to delete the first one, which is the correct one. Okay, so now I've made a change. How do we push that change for review and approval? So we go to create review. We export to GitHub. Now, what this will do is on your own GitHub repository, your GitHub account, you can make it will automatically make what's called a fork of the sort of master version of the information. It will use the details we saw before. In this case, it takes everything from a GitHub thing called Freebird. Because it uses your account, you need to give it a token, which is very easy to find and provide. I'm going to say export my change, this change of one CubeLink item, to GitHub. And so it's going to create a fork of the official version, make the change in the fork, and then it's going to send to someone who owns the official version a request to say, hey, I've made a change, can you approve it, review it, accept it, or reject it? So this takes maybe a minute. Let's pause it. Oh no, sorry, it's there. Let's say I made a fork. We can look at the fork. And it's made what's called a pull request. The fork has, it's called Freebird 1 here. It includes some of our changes. These are described as a set of files. And then here's a pull request that goes to the authority and says, hey, I've made a change. Will you accept it or not? So it does some automated tests on the change, and then it allows the reviewing party to say it's got to merge it into the official version, or they can start a dialogue and say, well, we don't like this change, or we do like this change, etc. Here we have the number of files changed. Probably it was in cube structure item links. So we can actually see the changes that were made. This has been improved slightly, but we can see the changes that were made. Now, what if I was the reviewing user? How would I review this change? Well, we'd go back to the dashboard, and instead of saying get this from the master GitHub, we would say get it from the fork. So the adapted version, and we get it from the particular branch that was created. Sorry, excuse me. So it's not the main branch, but this particular branch that was made. Save that configuration. And then we'll do the process again. We'll retrieve the artifacts, make the database, and then we'll be able to see the changes. So let's click Retrieve Artifacts. Takes a minute, so we'll pause. Set up the database again. Takes a couple of minutes, so we'll pause. So that's completed, and this time we won't redo the creation of the SMCube's transformation rules. We will load in the version that was created last time. So we clone, basically, instead of redoing the steps 1 and 2, we clone the result that was created by steps 1 and 2. We clone the database. So we'll click this button here, and it'll clone from Freebird1 from our fork. Takes a bit of time. Okay, that clone is completed, and so we'll see steps 1 and 2 are marked as done, though actually we just cloned the database to reflect what the steps we've done before. And if we do review and edit the cube links, and we go to look at the thing that we edited before, in this case we're acting as reviewer, we're looking at the changes. Then we'll see that this time the change is reflected. So we previously changed institutional sector to come from party type instead of institutional sector on the party table. Completely wrong as a change, but we see that the change has been made. We can review it. We can also then recreate the Python code and run the tests again. So as soon as we've made a change, the person changing it can run the tests, and then the person reviewing it can run the tests. Also, this is very important. This is how we get good quality from fast iteration. It's often called continuous integration or continuous development, but we make changes, we test them, we have them reviewed, and then we contribute them to what we call the master branch. So we're making reliable, well-tested changes frequently and keeping things flowing very smoothly. So as a reviewer, I'm going to say that I like this change, and then I'm going to look at what was called the pull request. So let me find it. Here it was again on Freebird. So a request to merge from this branch that was made by the contributor into the main to say this is going to become part of the official version. It says all checks, there's some automated checks have passed, no conflicts, and I can click merge, and that will make that change now be part of the new master branch. So a very efficient pipeline for making changes, getting them reviewed, and then getting them into the core thing in a way that's tested and tested against executable transformations, and to keep the process moving fast and smoothly with great quality. So I hope you found that interesting. Thank you for watching.